So in principle of staging is to gain high final velocity to arrive the required destination on time. So for that purpose, a number of techniques are there. So parallel staging means just stacking one fully furnished rocket into one over another. Then we can create long and efficient rockets. So this is one of staging, means having first stage we call booster stage, next stage remaining next stages are sustainer, and the final stage there is payload on it. So always at the top of final stage we can find the payload, and every stage are dropped at the end of finishing the propellant. So that is the technique. So let's see what the serial staging means. So instead, sometimes you can say it has tandem staging. So the first stage integrates ignite at the launch and burns through its fuel until its propellant are fully consumed. Now the dead weight means the structure, the remaining structure, or the rocket chamber and other components. In a stage maneuver, the first stage breaks free from the previous stage. That means we discard the first stage once the full propellant is done. The first engine, stage engines, then the second engine is extinguished. Means then the next stage should be ignited. And, once we discard the first stage, the next will be ignited. And then in such manner, all the stages will be performed like that. So we can see here one of the serial staging technique. So even though in serial staging technique, we may have a number of nozzles here at the initial position in order to get high performance or high boosting of the rocket. So the payload is carried at top of the second, top of all the stages, not the second or not the third. It is at the top. All important payloads are here. As I told you before, maximum weight of the rocket is of the fuel and its component. So the only about 2% or 1.some% of the total mass of the rocket is the payload and the important equipment. Okay, so which are placed at the top of the rocket. So we can see the Saturn V moon rocket. This Saturn V moon rocket, and it is flight fast. So initial mass, you see, the initial mass of this rocket is about millions of kilograms. And then when discarded the first stage, the remaining mass is about 500,000. This is less than 500,000. Here it is greater than 2 million kilograms. So 500,000 or less than 500,000 of the weight is left. And then when it goes to there, it is about 118,000 kilograms. And also at the final, that also after the third stage, we get this. Means after accomplishing 2,542 meters, or just 2.5. This is actually not meter but kilometer. Okay, so these are kilometers. So this is the way how the rockets or the serial staging works. So when we come to parallel staging, when we need heavy lift at the very beginning of launching, we need heavy lift. Then this type of arrangement is preferable. So the rockets have 2 or more solid boosters on it. In this case, you can see 2 boosters, or like this, 1 booster here, another second booster. So these boosters, before powering or before discarding, they go like this. The main rocket is there. It gives thrust. Again, this second also do the same. Third also do the same. And once it discards, the main sustainer will continue to fly like this. This is the sustainer one. Here also the same, this the sustainer condition. So the flight is like this. And these are fallen down to the ocean. This will fall down to the ocean. So in parallel staging, several small first stage or booster rockets are strapped into central sustainer rocket. So this is the central sustainer rocket. At launch, all of the strap-on engines are ignited, and once all the propellants are consumed, they will be dropped or discarded from the main sustainer rocket. Then the weight loss will, high weight loss will be accompanied with high change of velocity. So the discarded solid rocket boosters are retrieved from the ocean when sometimes they use it, refill it with propellant and reuse. For reuse purpose, it is discarded to the oceans. So the sustainer engine continue burning its payload, which carries atop the sustainer rocket into the orbit. Now the next one is serial parallel staging. As I told you, there is a combination of the two will help. So which is done or which is performed in Titan rockets. Titan 3s and the Delta 2 rockets used this type of technique. So after the booster or solid propellants are discarded, the sustainer engine burn until its fuel is extinguished. Then the second stage of the Titan, this is just telling about the Titan 2 and the 3 rocket condition. So that is the technique of using or getting advantage of the 2 type of configuration. There is also some system or which is a single engine that is called single stage to orbit or SSTO. This single stage to orbit or SSTO, the vehicle reaches orbit from the surface of the body using only one propellant and propellant and the fluid. Means the engine is only one engine, so it goes with one engine only. But this one is very difficult because there is no separation of dead weight like once the fuel consumed, still the structure is attached with it. But those previous advantages are not there. So this type are fully a reusable vehicle. We can take this type of engines like there are some, for example, this one is the best example, the Venture Star, which was proposed in the SSTO space plane. So these are the staging techniques. Why we are learning staging in our future class, we'll separately see how the structural mass affects in every stage, how the pilot actually pilot and the structural mass, even though they are constant, but whenever we are dropping them, then how we can get more efficient, especially the efficiency of rocket. The part we will learn in the next class, maybe the efficiency of the rocket. So on that, we can see those things. Now another concept is known as ascent trajectory. Before that, let me finish this. So this single stage to orbit vehicles are so attractive because they eliminate cost. Actually, even though they are difficult to gain high propulsive speed, but still they are efficient in the case of cost, in the case of complexity, in case of reliability. Okay, so in the case of staging, we may have faced some complexity of assembling those different components together and getting their advantage every moment. So a lot of complexity is there, but in this case, no such complexity. However, it's extremely difficult to build such vehicle with today's technology because using only single or engine to arrive to the maximum destination is very difficult. So that is some of the difficulty of this type of. Now, when we come to ascent trajectory, dropping of the stage helps in minimizing weight. Look, when we are dropping stage, we minimize the overall weight and helps to accelerate the rest of the vehicle much faster. This is the intention of staging. As a result, less propellant is required to reach the desired orbit. In the case of staging, less propellant is required. In every stage, we put some amount of propellant, so that will give us an efficient movement or velocity, then that discard. But so such space launch vehicles deliver payload into orbit by moving so fast that they can overcome Earth's gravity, and after they reach to desired altitude by and then they release the payload at very high speed. So this is just a trajectory. The fast followed by the space vehicle is we call trajectory. So, so look, this is the point where the launch vehicle is, the vehicle is launched, or it is called the launch pad. Okay, then first stage be discarded from this point, and it goes through the atmospheric flight. Then once again, it goes to the next flight position. So we have some ground station we control, or we check the trajectory of the vehicle. So it goes like this. Second stage be dropped here, okay, and then the third stage will take place. Then it go like this only. So this we call, it is called the ascent trajectory. So almost all rocket power launch vehicles are launched vertically from the ground, and they usually try to get out of the dense atmosphere as soon as possible. So that's why we need the space escape velocity about 11.2, which can help us to move the vehicle against the gravity. For that, the vehicle must be moved beyond or at least on space escape velocity. Yeah? So we have to leave the dense atmosphere at very fast speed. However, the ascent is too steep if we are using steep ascent like vertical flight. Vertical flight is not advisable. It is, we must make some kind of horizontal tilting with some controlled manner. So this steep kind of moving is not advisable. On that, we need a lot of energy. If we are using, why we are using I thought space vehicle, Earth's orbit like it goes to the Earth's orbit. Then I remember just 2 years before, the Indian rocket that the name called, I think, Chandrayaan, like that. That rocket initially launched to the Earth's orbit, means lower Earth's orbit, and on the lower Earth's orbit, the rocket moved 3 times on the 3 rounds of the Earth's orbit, and then have gained maximum velocity to escape from the ground. I prefer this one. The ISRO, when the India Space Science Show, one time escape ለማድረግ ከፍተኛ የሆነ ኢነርጂ ነው የምፈልገው። ያ ኤነርጂ ደግሞ ካሉ እንትን ማግኘት ከባድ ነው። ስለዚህ ያለው አማራጭ ምንድነው? በኤርዝ ኦርቢት ላይ አንድ ዙር በሄደ ቁጥር የሆነ ቬሎሲቲ ጌን ያደርጋል። ሁለተኛ ዙር፣ ሶስተኛ ዙር የመሬትን ኦርቢት በመዞር ከፍተኛ የሆነ ፍጥነት ሲያገኝ በዛው ነው ስፔስን ለቆ የሚወጣው ወይም አትሞስፌርን የለቀቀው። That is the technique that Indian scientists use. አንዳንዶቹ ደግሞ በሃይ ኤነርጂ ዋን ታይም ቨርቲካል ላውንቺንግ በማድረግ ኤርዝን አትሞስፌር ፔኔትሬት ያደርጉታል ማለት ነው። For that it needs high energy source. So it spends a lot of energy to lift the propellant at high altitude, which causes gravitational loss. Therefore, the launch vehicles turn down gradually to have almost horizontal acceleration after leaving the atmosphere. So that is the technique. Okay, you see here, initially it goes to an appropriate position on the Earth. Then the launch will be launched from this point. So it goes like this on Earth's lower orbit. So this is the launch vehicle trajectory on it is Y2 orbit. So after that it goes to it is on orbit. ምን ይመስላል? ወደ ሙን በሚሄድበት ጊዜ ወይም ደግሞ ወደ ማርስ የማርስ ሚሽን ይሄ ኤርዝ ቢሆን ማርስ እዚህ ጋር ቢኖር ብዙ ጊዜ ኤርዝ ላይ እንደዚህ ዞሮ ነው የሚሄደው። እንዲህ ዞሮ ማርስን ላይ ዳይሬክትሊ ሄዶ እንትን አያደርግም። እንደዚህ ዞሮ 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 ነው የማርስን ላንድ የሚያደርገው። Look, this is the Mars, this is Earth. ይሄ በምን ምክንያት ነው? በአንድ ጊዜ ዳይሬክት ፍላይት ቢያደርግ ከዚህ እስከዚህ በአጭር ጊዜ ውስጥ መድረስ ይቻላል። ግን ያን ለማድረግ ኢነርጂ ያስፈልጋል። ለዛ የሚሆን ኢነርጂ ደግሞ የለም። ስለዚህ ያለው አማራጭ ምንድነው? ቬሎሲቲ ጌን በማድረግ በእያንዳንዱ ፕላኔት ዙሪያ ላይ ቬሎሲቲ ጌን በማድረግ እና ኦርቢትን እየለቀቁ በመሄድ የሚደረግ ነው። So this is called the trajectory. So the path followed by the launch vehicle from the ground to its orbit is known as ascent trajectory, and ascent trajectory depends on the location of the launch site. It depends on the location of launch. There are appropriate launch sites which can help us with less gravitational force. It also depends on the propulsive mechanisms, and it also depends on the gravitational field. Means gravity is not constant on Earth's surface everywhere. So we select less gravitational field area for easy launching. And it also depends on the aerodynamic force. That aerodynamic force is the force generated from our vehicle itself, acting on the vehicle, okay? And also we have some safety and operational constraints on the trajectory. So these parameters should be considered while we are orbiting. So a small change in the ascent trajectory can have a significant effect. Look, a small change ባለፈው የሆነ ነገር ስናወራ ነበረ ወደ ስፔስ ደብሪስ ጉዳይ ስናወራ ሳምባዲ ጋር ዲስከስ ያደረግን መሰለኝ። እነዚህ ፔኔትሬተርስ ወይም ደግሞ ስፔስ ደብሪን ዳይሬክሽን ቼንጅ የሚያደርጉ ነገሮች ከመሬት ላውንች ተደርጎ መሬትን እንዳይጎዳ እነዚህ ላይክ አስትሮይድ በሚመጣበት ጊዜ ከመሬት ላውንች የተደረገው ስሞል ኦብጀክት የአስትሮይድን አቅጣጫ ያስቀይራል የሚል ነገር አውርተን ነበር። So this also works here for our space vehicle also. So if there is a small change in the ascent trajectory, that results in a significant effect on the complete path of the flight, or on the payload mass that can deliver into a specified orbit. Therefore, we must consider an optimum trajectory condition. So, hello? So we must consider the optimum trajectory optimization is required to achieve the best performance. Okay, so that is the meaning. The second one is spacecraft itself. What we have discussed all is space launch vehicle. እስካሁን ያወራነው ምንድነው? ስለ ስፔስ ላውንች ቫይክል ነው። ስለዚህ ሁለተኛችን ምንድነው? ስፔስ ክራፍት itself. So the spacecraft is a vehicle, as we have discussed at the very beginning. It is a machine or a vehicle or something which fly to the outer space from the Earth's surface. The best example is artificial satellites or the space station. Satellites on the space stations. The satellites on the GPS, which control our daily activity. So, which are spacecrafts which are used for a variety of purposes, including communication, including Earth's observation, for meteorology. This dimensional meteorology means weather forecasting purpose. Okay, this meteorology is not so this is weather forecasting, again for the navigation purpose, for space colonization and for space planetary explorations, and also for transportation of human and the cargos. So many spacecrafts transport human from the Earth's surface to the moon, from the Earth's surface to the Mars, still okay, and also to the international space stations also. Tourists also go to international space stations. Okay, so these all purposes are of the spacecraft. So spacecrafts can be piloted or unpiloted. That unmanned or piloted is known as manned spacecraft, and unmanned or unpiloted one is the unmanned spacecraft. And depending on its application, they are classified as interplanetary, or for planet to planet move, like the spacecraft which goes to the Mars, that we call planet to planet or planetary spacecraft. Manned or unmanned, just based on the crew member or there or not. Trans-solar space vehicles. And some of the primary functions of spacecraft are for orbital insertion, for orbit changing maneuvers, and for space flight. So these are the applications. So this is one of the Soviet Union spacecraft, which is first spacecraft program, which was launched in 1961 with Yuri Gagarin. Okay, he's the first person who human being who got into space. So the capsule he used was the Vostok 1. The capsule cost Vostok 1, which is so the second, just after the Russian Vostok 1 launched to space with Yuri Gagarin, US also started flying such spacecraft with the advice of the American president during that time. His name I forgot. So in 1961, once they observed the space exploration is possible, then they started to launch a spacecraft to moon. That is done by USA in 1968. Okay. So the capsule was the Apollo capsule. This is the Apollo capsule, which is landed on the moon for the first time with manned spacecraft. Okay. ማን ነበረ የአሜሪካን ፕሬዚዳንት የዛ ጊዜ? Anyways, that is the kind of history. So the second function of spacecraft includes the attitude control, the spine control, momentum wheel and the gyro unloading, stage separation. These are secondary functions. Primary functions are orbit insertion is primary function, orbit changing maneuver, and the space flights are primary functions. So these are considered secondary functions. So in order to execute the function, the spacecraft can carry a number of rocket engines. That's what we call staging. So small rockets with short burst of thrust are also being the part of this in the attitude control system. Yeah, so this is the first actually crewed spacecraft, that is Vostok 1. Okay, it is designed like this. Even Yuri Gagarin checked the Earth through some of the glass which provide for visual looking to the Earth. So this is the Yuri Gagarin spacecraft. Mercury, also the second one, which is the first American spaceship. Okay, after the Yuri Gagarin, they sent another astronaut. Again, Vostok 2, the second version of Vostok by Russia also. Germany, these are some of the spacecraft launched. Suez in 1967, so this is also. Apollo, that in 1969, that have some lunar mission. It's sent to perform some lunar mission that sent to moon for the first time. Okay, so and this contains what's going on. Hello. Hello.
We are following you.
Yes, Amachu, you know?
Oh.
I don't know, some እኔ ጋር ትንሽ ዲስታርብ እያደረገ ነው እንትኑ ዙም
10 ሚኒት ብሏል ለመዝጋት መሰለኝ ነው።
እናንተ ጋር ይታያችኋል?
ይታያል።
ግን ዙም እንትን ብሎኛል እየረበሸኝ ነው። Okay, አሁን ይለቀቀኝ ይመስለኛል። So this is the first moon mission that is done by Apollo in 1960. So this is one of the spacecraft. The spacecraft were designed to carry more astronauts, including 12 people who have walked on the lunar surface. So this is the first spacecraft which reached to the moon and come back to the Earth. So the Apollo command module was only meant to transport to and from Earth. Okay, so to and from Earth mission is done from this time onward. The lunar module was also able to attach and detach from the Columbia. Actually, this Columbia was the one which have faced some accident. And one of the USA spacecraft, manned spacecraft, which is faced some problems. So they use some lunar module from that itself. Space Shuttle in 1981. So these are all about. And let me come to. We have 8 minutes. Within that, let's discuss about the missile. So missiles are actually military weapons. Now we are coming to military weapons, which are a guided airborne weapons and which are self-propelled flights, which can perform self-propelled flights. Okay. So missile, a rocket-propelled weapon designed to deliver an explosive warhead. Look, the main intention of missile is to deliver explosive warhead to some place, from one place on the earth to another place with great accuracy. Because why great accuracy required the target to get appropriate target, great accuracy is required. Okay, so the accuracy in high speed. So in general, we call missile is a rocket propelled weapon designed to deliver explosive with great accuracy at high speed, where it delivers this explosive to the target. Okay, target is them. So missiles vary from a small tactical missile, small tactical weapon, to the large intercontinental ballistics. Okay, it ranges from small rockets or a small tactical missile to large strategic or intercontinental ballistics. That is the range of missile. Missiles have 5 systems. One is the targeting system. Another is the guidance system. That there is guidance and the control system. There is flight system. There is engine and the warhead. So from this is the one which expected to deliver to the target place in high precision. So this is a simple constructional feature of guided missile. Okay, so this is the guidance and the system of the missile. On that, there is also fuel tank is there. There is firing chamber. There is external control surface. There are flight control surface are also required in missiles. That contains some wings and pins. So the motion dynamics is stabilized with the help of control surfaces. Appropriate pin design is required. Appropriate wing, small wings, which we sometimes call canard wings, or so on. So they are also required. There is outer skin, which can resist very high speed with high friction. Fuel pumps are also required. Internal control surfaces are also required. Okay, some blast and shock wave that produce from the thrust or the exhaust will be there. Gyroscopic stabilizer means some control systems are there. Payload, which is known as the warhead, which is also there. So this is a simple constructional feature of tactical missile. So this is, for example, here you can see the small pin. This is called pin. This is called control surface. You can see here wing. And there is warhead around here. That is the main component. Okay, this is the structural part. Okay, and this show you the sectional including the internal view. Missile can be broadly divided into two. One is the ballistic missile, and another is the cruise missile. So what are these ballistic and the cruise? We can identify them after some discussion. So ballistic missile follow a ballistic trajectory. Okay, flight fast means trajectory. Always when I say flight fast, it is trajectory. So it follows ballistic trajectory to deliver the warhead to a particular target. So there is in initial point, there is final point or destination point. The destination point is called target here. So the phase followed by initial point to the destination is known as the trajectory of the flight. So the initial point is the launch pad or the launch system. Most of the time, maybe they're launched from the ground, they're launched from the boats or ships or some of them are launched from the water body known as, for example, one of the missile which goes through the water body is known as torpedo. We call it as torpedo. So those are the missile types. The ballistic missiles are preferred for long range. So long range and land attack mission. It performs a land attack missions where accuracy is not very important. Actually, accuracy is important, but it performs on the land missions. And the missile can launch from mobile launcher. Sometimes we launch it from mobile. Actually, there are small missiles which we can launch from some patrol cars, like, okay. We launch it from mobile launcher. We launch it from ships. We launch it from marine. That submarine missiles are from the marine, like torpedo is the one, and we launch it from the ground cells. So these are the launch pads. Okay. The long-range intercontinental ballistic, we call it as ICBM. Okay, intercontinental ballistics are called ICBM, which are designed for and developed by several countries these days to carry nuclear warhead. Actually,